Alright, welcome everybody to my talk. I am very happy to be here. I had a bit of audio trouble before. If that happens, Evan is going to interrupt me and I'm going to switch the mic, but hopefully this is going to be great for everybody and everybody is going to enjoy my talk. I'm going to talk to you today about transforming SwiftUI to JSON and vice versa for fully backend-driven UI. The talk is a little bit about when you need that extra bit of flexibility and you can't just compile it ahead of time. So we're going to talk about that today. I'm going to introduce you about a framework that I've built in the past year and a half. Before we start, I want to just say a little tidbit about myself, not too much. I've been developing iOS, or for the iPhone OS back then, for a little over 10 years now. I currently work remotely from my home in Atlanta, or actually outside of Atlanta, for Betterment. The worst thing that can happen to me in a career is to working on move this UI button 5 pixel left stories. That's not what I interviewed for or went to school for, and that's what this talk is going to be about a little bit. If you have any questions after this talk, please feel free to reach out to me. I'm Caffeine Flow on Twitter, and as you can tell from the picture, I'm obviously a dog fanatic, and if you hear something snoring, that's my dog next to me. A tiny bit about Betterment too. We are a investment IRA and 401k provider with best-in-class automated investing strategies and human advisor. We have a very strong engineering team and culture. I believe a couple of my colleagues are here. Thank you so much for coming. We have offices in New York, Philly, and Denver, and we have remote positions available. Like everybody else, we are hiring. If you're interested, feel free to reach out to me afterwards. But let's begin with this talk. What do I want to do today? What do I want to achieve today in this talk? Well, first and foremost, I know Zoom fatigue is a real thing and people are getting tired over time. That's why I want to make it a priority that this talk is going to be a little entertaining. That's why there are memes in here. I do want it to be informative, so I want you guys to inform about a topic, right? And the topic is going to be SwiftUI transformation to JSON. But first and foremost, I want it to be fun. So altogether, I want this a little bit to be like Ted Lasso on Apple TV. Just that Ted is Florian. Ted is not from Great Britain anymore, but from Germany. And it's not Jason Sudeikis, but it's Florian Harr. So let's dive right into the topic. I know we have a couple of folks here that might be Android engineers. So we have a couple of folks here that are Flutter engineers or any kind of other platform. So what is the JSON plus SwiftUI part about? Well, we want to use JSON as a transport medium or a transport format in addition to the declarative UI framework that is SwiftUI to build apps. In itself, that is nothing new, and as this has been done thousands of times, as the App Store can obviously tell. There's massive amounts of apps that use SwiftUI today, and they all use it in one way or another. So to give you a small introduction, I want to show you how this can be done very easily in the most basic steps. Generally, there are two parts of how you can build a iOS app with SwiftUI and JSON. The first one being that you have like your view. On the left-hand side in the code, we see here the item detail view that inherits from the protocol or implements the protocol view. Therefore, it needs to create a body. In the body, you declaratively say you have a V stack, and the V stack could have multiple other stacks, in this case a C stack, and you give it UI elements that then pop up basically and are being drawn on your screen. The fun part here is that we have also a item, which is a menu item, and the view itself knows how to display the item information given here. So very much like I said, the item, and then you have like several times, for example, on the text field, you say that this photo has a text, which is the photo credit. You could spin this a little further when you have like these, what I want to call parameterized views, and say you have an order that is an observable object. So this is a object that if it changes will actually notify anybody that is viewing it or that is actually observing it that it has changed. And so you have an order where you have a published item or a list of published items. And then you have your IDON app at the bottom where you have like an order and that is being passed down into the app so that your app controls this one order. Parameterized views, one way to do an iOS app with SwiftUI and JSON. The second part that we could do is being a little bit more dynamic. You could have a home view that, for example, only ever shows up if the user is logged in. So you have another view that is a SwiftUI view, and based on the current state of the app, which could also be coming from a JSON value or coming from a remote API, you are going to check if the user is logged in or what the parameters are from your JSON. And if that is happening, you're logged in, you actually show the profile view for the user, or otherwise you show the login view. This very same thing can happen on the right hand side, where you have like a list view and you have a selected item, a binding that is reactively changing towards the binding. I want to call these dynamic views, like based on the shipped views that we have shipped at compile time. You are assembling views based on the API or the data that you give it at runtime. So if we look at it very shortly again, the parameterized views are exactly the same as I said. Like you have a title view, which would be here the hello DevCommunity, or you have a list view that shows a list of items, which you then display in a list. And if you put that together, that's what it would look like in a VStack on this on your iPhone app, right? So summarized very shortly as the first method of building SwiftUI JSON apps, you can initialize views from a backing data structure that could be anything, a codable JSON model. It works very, very nicely if you have screens that don't change too much, because a lot of these views you need to initialize at a time. You don't want to build all the if-else clauses for your JSON API input to build different variations. And from a development experience, it's a very, very clear implementation experience, since you're essentially calling title view, open parentheses, and say like, this is my title, and then your parameters, the modifiers, everything that you put in there is going to be static. And if you deliver it to the App Store, that's what it's going to stay, static. I am not an expert on these types of building JSON and SwiftUI apps. I want to show you something else. So here are some follow-up resources that you can use, and I'm going to post the slide which has the links in it afterwards. That actually has a lot more tutorials on how to build a parameterized SwiftUI view. The second part I want to come to is the dynamic screens with shipped views, right? So like I showed in the first example, you might have a login view that has the login view parameters in there. So you have two text fields, a username and a password text field, and a login button that takes the input from these two fields and then logs you in. And you might only need to display your home view then, which takes the state of your app and says well, you're logged in or not, right? And based on the login, it will output the result here. I made a little GIF from it. And if you look at it, if we type in the username, we type in a password, it is actually plain text. And then you click the login button, it will, based on the input that you gave it to, which was the username and password, change to the screen that you want it to, right? So this could also be driven from an API. Again, to summarize this method of building a SwiftUI app with JSON backings data structures, it's an evolution to the parameterized views, because you are actually reading dynamically at runtime an API, and from that runtime you are actually building the view, and it could have different layouts. So you compose different screens from sets of shipped views remotely, which means if your data structure and you are getting data models, right? So you're getting a model from an API in, changes at runtime, it could build dynamic screens based on that, right? Again, very shortly, follow-up resources here. There are other people that have spent way more time on this and have better writing than I did. What I want to talk to you today about is how can we do the next step from that? How can we be getting rid of the chains that are either parameterized or dynamic views and completely get boundless from the way these bounds are given to us, and just use everything dynamically from a web resource. So my question to you is, do you hate UI bugs after that you notice after you've shipped something? Or would you like to update your UI without ever having to release a new version? Or would you rather spend your time on actual features that you innovate for? I tell you, Apple certainly does want to do that, and I'll show you how you can do this better. there's just this one weird SwiftUI trick that I have to show you, and let me show you how that works. So we've seen the evolution. What if I'm gonna use my view that I have with the view protocol that is mostly always a struct, and I use the part that is the struct and I add the codable synthesis to it. And because it's a struct, the compiler, the Swift compiler, will automatically synthesize all the properties on the struct for me and make it possible for me that I can transform everything into JSON, and instead of transforming JSON or my data model into my views, why do I not completely go like one step further and just completely transform my build hierarchy, my view hierarchy into a JSON stream and then decode it? Sounds nice, right? Because now I no longer need to only consume JSON with the data, but I can consume JSON and actually show the full data stack for it, right? Or the full view stack for it. That sounds a little bit to me like it's an evolution. As first we have the static screens with the parameterized views, then we have the dynamic screens composed of shipped views, and it's the third evolution, we have the SwiftUI view that is codable. A little bit like the expanding brain meme, where we have like, as a very beginning, you start out with parameterized views, then you put your data into your views and make like new shipped views from it that you can potentially still like display in your app and make new screens from it. And then there's the expanded brain, where you just like put the whole view hierarchy into JSON. So let me show you how this is done. We're gonna do a live demo. All right. So if everybody is still seeing my screen, you should be seeing a text view in a iPhone 13 Pro Max iOS 15 simulator on the right hand side, and on the left hand side we have a Visual Studio Code that shows this JSON output that could be a REST API. So what we have here is a hierarchy or a JSON document that is describing how my view should look like. It is describing essentially what I'm going to bring onto the screen on the right hand side. Here we say we want a text field with an alignment of center and the content, hello DevCommunity, how are you today? All I'm doing on the Xcode side, which I'm going to show you in a little bit, is that I'm going to monitor the JSON file, and if the JSON file changes, my simulator updates. So what if I enter a line break and I save it? Well, it automatically updates in my SwiftUI view. So far, so much fun. But let's say I'm gonna go completely nuts about it, and I'm going to add like a VStack into it. And I say I want a type of VStack, and I want views to it because a VStack has multiple views. And let's say
Florian, Florian, can you zoom in a little bit on your editor? Thank you.
Yeah, absolutely. Well, that is not what I wanted. Give me a second. So, zoom in. Is that better?
We'll see. Yeah, you can just continue. Yeah.
All right. I zoomed in again. Let me know if this doesn't work. I'll zoom in one more, and then we're free in. So I've added three text fields to it in a VStack, and so if I'm gonna save this should update. I think that is already nice. But let's say I'm going to add like I'm removing this first like text, and I'm going to make it an image, and say the image URL is going to be my image now, which I have here. And I update it, and my view updates, which is a pretty new paradigm if you're in the SwiftUI world. So let's say I want to like go one more, and I want to say like this like VStack that I have here, I want to wrap in one more deeper, and I want to say like now I want this all to be in a list, and the list again has views that are a list of views, and if I save it, I actually have a list that has all my elements in here. So much fun. Or so far, so much fun. Like, let's say in the list, in my VStack, I wanted to have like one more view outside that is potentially another type image, and it wants to be a URL for a different image, which I'm going to use the last meme I copied. Well, probably not that, since it's just an icon. But let's say that must have been it. We want to add that. Now we have another image underneath my list, and it's all dynamically built at runtime without ever having to recompile. To show you a little bit how this is working, all this is doing is essentially I'm having an enum that actually has a associated value of the SwiftUI view type. It could be different values. Here I try to go minimalistic to the atomic elementary level, that is the SwiftUI views that I have. And then all I need to do is having a view factory that is a view builder protocol, so it can dynamically restructure the view that is being displayed on my iPhone simulator. And everything that I need to do then is to say like, well, give me the decoded JSON that I'm getting here. So it's the decoded JSON that is the paradigm change, where I no longer have data encoded in the JSON or the data entity itself, but the view hierarchy itself. And then I say like, well, every time this changes, push it through the view factory, and the view factory give me my views for it, build up the view hierarchy and display it for me. Nice, isn't it? So let's get back to the presentation. So as I mentioned, from a change or from the architectural perspective how this works, you have JSON on the left-hand side that you're getting into your app. That goes for a deserializer or the view factory, which gives me the decoded SwiftUI view, all happening at runtime. If we look at it from a little bit of a higher perspective, how this could work in production app that is actually live in the App Store, is it could be your user has a user input, which makes the iPhone or your operating system or your app in this case send a request to an API server, and that request could include all kinds of parameters from which page they are looking at, to the device type, to the version. The API server then generates the SwiftUI format for you, sends it over the wire to you, you receive it as a JSON, your deserializer uses it, builds the view factory from it, and therefore dynamically builds the decoded SwiftUI view for you. For a very bare example to show you again the JSON code that we just looked at, this could be, in this case, you have a type of a list that has an array for views, which could have again another VStack, and that builds up the hierarchy that we see on the right hand side, where you have a list that contains a stack, that contains the image that we put in, and then the text that we built underneath.
Florian, Florian, there's some audio problem. Yeah.
All right, let me fix that.
All right, is that better?
Yes, it's better. Thank you.
All right. So from a perspective, to repeat what I just said in case my voice went robotic again, we have the list on the right hand side in the hierarchy, we have a stack underneath, and then you have your image view and your text that is being represented in JSON, like you see it on the left hand side. It actually represents one-to-one the view hierarchy, which is the same view hierarchy that SwiftUI builds internally. And from there, you are getting something like this, where you put in a native views. This is not being drawn on the screen or anything like it. It is actually native SwiftUI views that are being built at runtime on your screen. If you wanted to go a step further, there is a bonus. That is the abstraction, right? If you are going the way that I went in this repository that is also open source, then you could build a protocol decodable view variant, which would have an ID, so it's identifiable, a padding, so every any codable view variant that you have had a padding, and then you had a enum that is decodable view, which represents any kind of view that you can actually read from JSON. It's a little bit like a low-key variant, but instead of a low-key variant, it's a codable view variant and takes many different forms. It could be a text component that, again, is a struct that could be decodable. Or it could be a text view, anything that you'd like. The idea here is that you get so granular and that you basically rebuild anything that you have in the SwiftUI foundational UI library into like your Swift server-side driven like a framework, so that you can basically at runtime rebuild anything that you could build at compile time already, which makes this very nice. The deserializer on the left-hand side is something that John Sandel from Swift by Sandel wrote an article about. It's linked underneath. It's essentially, you're just reading based on the type item that you're getting from the JSON, what you have to decode. Then you decode it into the associated volume enum, and then you put it through the view factory that you see on the right-hand side. The key here being the view builder statement, so that it's actually like a view builder function that will consecutively be able to read like the DSL that you're writing. I want to show one more live demo, because if we look at that screen, I've also mentioned the button, and I wanted to show you guys the button. All right, so what if we wanted to have a couple of text fields instead of the list that we had here? And we say like we want a text field that has an alignment. And we say that should be center. And we wanted to have a title for the text field. That's, let's say, is a form field number 1. So that gives me a form field right here that gives me the possibility to type in any kind of content that I want in here. But let's say we want this to be in a stack, because if you have or in a list, because if we have a form that we wanted to rebuild and we have a type list that has, again, views, right? And those views that we have in here, right, would be my text fields, right? So now we have a form field number 1, right? Now, because we wanted to build that live, right, we could be saying like above this, we want another view that is, again, from the type. That would be a text, right? And we know that the text has a content, and we want to say this is input field number 1. And now we are getting an error. I forgot the alignment, I believe, which the text field needs. Center. All right. And so now we have the form field, we have the text field, and these two things. And let's say we also want a button. Now the button is a little bit trickier, and we're going to come to that in a second. But if we wanted a button, right, then essentially we need to say like we have a type that is button, and then I'm going to look it up into my library, because I am not very good at like remembering the button over time. So let's say we want that button, and it has an action which I call open URL. I want to say it has a content that is the name that I wanted to give it, and then basically a parameter, which could be the URL or anything you want it to be. So let's say we have that button in here, and then we put the URL in here, or we say open URL, and then we have an open site. Now, if we click that button, dynamically, it actually uses the selector, the Objective-C message send that everything in Swift basically relies on, or at least in parts until Swift 4, that we can dynamically call any function that we have actually allowed. If we look again at how this is being implemented, then I want to mention 2 things here. I highly recommend you to set a list of allowed actions, or somehow retrieve a list of allowed actions, because otherwise this could basically be calling anything that has an Objective-C tag to it, which could be rather dangerous. And we don't want to be dangerous people, right? And then you're basically performing the selector, which is dynamically built from the JSON that we're getting in. But that is a way how you can even have buttons built up, and how you can do different things. So to show you what this could look like, I've prepared a couple of different things that we could have here. We could make this an input field with an image in between on the list, and we have a list, a VStack, and then 2 VStack split. This could be let me see what else we have. This could be a list or a list intro, which I showed you earlier. And you can build whole screens, like I said, with it. We basically bring everything into your app. And if you add like a VStack around it, for example, then SwiftUI will be automatically putting this as a title for the screen. And you can build, like I said, full apps with this. So let's get back to the presentation. And let's see what else there is. So there's a couple of things that you might be asking yourself at this point. So how do you create like valid SwiftUI JSON code? Well, this is a very good question, because potentially you want to build like this code that is actually run in production from your production app at runtime. And you want to make sure it's validated. You want to make sure that whatever you're building, whatever you're pushing out to the App Store, and whatever you're giving from your REST API is actually readable without a crash on your app, right? So at the time that I was building this for a major newspaper in the United States, we were building a what you see is what you get style of editor that was able to do that. And there are a couple of options that you can basically use for this, which I'm going to come to in a second. But if you're like me and you're a developer and you basically like the canvas that you get from the Xcode now, which gives you a preview, there are a couple of options that you can do. Here in this example, and I apologize for just remembering that that the font is not as big as it should be. You can build your view just as you build it in any other SwiftUI view. You need to put it around your codable views, so it's an actual enum, but then you can put it like the same way as you put any kind of JSON format that you want to like serialize again. Put it through the JSON encoder, encode it again like as a view that you got it from, and then you can print it to the console, for example, which is put it behind the untap gesture here. Just show it again. You bring up the view, you build it, for example, in your simulator, and then you encode it from the JSON encoder here on a click, which gives you the JSON code in your console. That's rather easy. The nice part here is like you only need to encode what you need, right? Like if you, for example, have accessibility traits, if you have anything that you want to add later, or if you have any kind of modifiers that you need that you don't need at the end of the day, debug modifiers, then you wouldn't need to encode those, which would help you to build like a debug version locally, and you only need to encode what you need for your production app later. The encodable extension you can build for standard views, so you wouldn't need to use the associated value enum that I've mentioned earlier, which is very nice because if you are able to do introspection, there is a nice library called SwiftUI introspection that helps you basically just build a extension or give any kind of standard views, for example, the SwiftUI.text struct. You can extend that to be codable, and then you can use SwiftUI introspection to read the view's property at a time when it's already drawn on your screen and encode it if you wanted to. Then you grab the JSON output from the console, like I mentioned, or if you wanted to go one step higher, and we'll talk about that at the very end again, is what you could build a what you see is what you get style of editor. Since SwiftUI also runs on macOS, you just have to go the next step of basically building these components out in a library, and then you can drag it into your screen and make it work that way so that you can like encode or decode like you feel later on. Now, we've talked about like this very complicated way, right, of making screens so dynamic that you can change them at a time that they're already in the App Store. And I see there's already like 11 chat messages on Zoom. I'm pretty sure someone is bringing up the topic of like, will Apple allow this? Actually, they did, and we've had like over the past 2 WWDCs, like several sessions with them where we talked about this. And they came to the conclusion that it's very similar to the web views that you're using, just that you're doing it in native. But is this a good option for you? Let's talk about the pros and cons. and when this is a very good use case for you. Well, so I've been mentioning the name server-side rendering. So what we are essentially here doing is, and you should keep that in mind, it's what we are doing is server-side rendering a SwiftUI page that is then being consumed at runtime on the client. I've been putting emphasis on runtime versus compile time because that's what it is that we are caring for, right? If we are looking on the left-hand side, we have the SwiftUI view on top, which could send a request, which requests a view from our backend server, which could be rather REST or GraphQL, whatever you actually use as your backend driver, which then would render the page based on the specs and parameters that you give it in, which could be anything from a device size to whatnot. You render it, which here could be the AWS Lambda, then returns a layout definition to your REST and GraphQL server, which then sends the JSON REST output to your SwiftUI view. That is a lot of flexibility that you can have there. But given that SwiftUI right now in its current state is not meant to be driven that way, it's a good bit of boilerplate code required to make this work. It's not as much as if you were to cover all the possibilities that are potentially there in a matrix. If you were going to go down the road of having dynamic screens that could potentially have any kinds of layouts, but there is a good bit of boilerplate code, which allows you to reimagine screens on the fly, something that is not otherwise possible, I would say. I think, to come to the pros about this, it's an excellent opportunity for mostly static content to be represented natively in mobile. The example I gave earlier with the username and password and the login button would be rather hard to implement, but not impossible, on a server-side rendered form, because you would potentially need to be able to capture the username and the password from the login button. And that is also like a security trait, because you would have to like pass these on. It's definitely possible, don't get me wrong, but if you have something static, like let's say the example that I bring here on the right-hand side, which is Apple News Plus, they're using something very similar. If you've ever looked at the JSON format that is Apple News Plus, it is very, very similar. And that's actually what Apple is doing, and what I think they will be going to in the next 2 to 4 years, probably with SwiftUI, where server-side rendering will be a component or a part of SwiftUI. If you currently have web views in your app to represent these kind of things, which happens quite often, right? Then these have their own challenges. We all know that the UI and the experience that you have lags a little bit behind what the native implementations look like. And oftentimes you have accessibility problems with that too. That was one of the reasons why we went for it back in my past job, where we implemented this framework on SwiftUI and Jetpack Compose to both unify the iOS and Android side to display the content the very same way, and also be able to have all the native stuff that accessibility brings us, all the native rendering, like dynamic fonts. We wanted to have all these things, and that was one way for us to do it. So I think after all the talking about this framework that I've been creating with a lot of people, it seems that consumable media, for example, news, are a very, very good thing. Another good use case example for this framework. Another example would be account user profiles with many edge cases. I was talking to someone that works in health insurance, where you have different health insurance plans, and your account overview looks very different based on that. And you would need to write 1,000 something like if-else cases just to make all the different view layouts work. And then you would still probably miss half of them and hit like half of these edge cases. That would be a lot easier for you to do if you were to write it from a server-side or server-side Swift rendering page, where you would bring that all together. You would write it once, and you would have these sent out to your clients to be displayed. Or, like I said, forms are a very good example. You can capture text fields relatively easy with bindings, and that would be definitely one way to do it. We talked about pros. Let's talk about cons. So I've mentioned like you're shipping something at a compile time, right? So you're shipping something to the App Store, and eventually what you're shipping today will not be enough tomorrow. And so at one point you will have to add versioning to it. It's relatively easy if you add versioning to it when you have GraphQL at the hand, but not everybody is using GraphQL, and that brings you into the misery of having to version stuff. That also brings you into the misery that you have like new variations that potentially your devices show differently. That would be rather hard to do then, and will add complexity on top of all of this. I've mentioned the button that had an action. Actions and function calls can be complex and dangerous. While we are working in the sandbox that our app is, you could still like steal data from that sandbox. We don't want to do that. And so you need to have check marks in place, like I had the allowed actions, to be able to make sure that these kind of stuff doesn't happen. In general, and that's what the meme to the right is about, and I want to talk about for a second. It's like technologies often solve specific problems. HTML, CSS, JavaScript, all these languages have been built for the purpose of like continuous delivery and being able to change these things rather fast, and also write a lot of throwaway code that displays something nicely in that moment and capture that moment. If that is your exact use case, then maybe you should consider if an inline or embedded web view isn't that. That was the thing that always boggled me about this when we built this for a long time. There was always one more modifier that we had to add to cover a certain edge case that a certain product manager came around. And every time we did that and delivered a new beta, I came to the moment where I was like, huh, is that the moment where we recreate HTML and CSS with extra steps? And usually I wouldn't get like much of a reaction other than like a grim face back. And that was the moment where I knew that I was hitting a nerve. So that is definitely something that can happen to you. I've mentioned what you see is what you get style of editors. During the creation of this talk, I came across tutor.app, which is doing the exact same thing that I just mentioned. It's essentially a what you see is what you get style of editor, where you put together your screens in your what you see is what you get style of editor. You make one click to another to like say basically this is a master detail view, or this is a detail view, and what action is behind a certain view. And if you were to save this in your iCloud Drive, which is an option to give you, and you do a right click, show package contents, you'll actually find a JSON file in it that is this descriptive for the layout. So what you're getting is a JSON that describes your layout and your functions behind it, very similar to what I showed you. There is another very like popular example that I would say 90% of the audience, just based on statistics, probably came across, which is the Hub framework from Spotify. Way prior to SwiftUI, Spotify already did the very same thing with UIKit, where this was also very possible to be done the very same way I showed you in SwiftUI, just a lot more complex because you had to deal with constraints and whatnot. And you didn't have the view builder functions that we have today. So they've been doing this for a long time. They've deprecated it because they went to another server-side render framework. But this is something that is out there and has been used for millions of users and has been fine. And that's also why some of the view controls, for example, in older Spotify versions, loaded so slow. JSONnet, on the other side, is using the exact same thing. If you ever came across it or want to look into it, they are doing native views basically with a descriptive JSON layout again, which is similar to what I've just described, and available frameworks here. That's it from my side. I'm going to be here for the rest of the day in the Slack, and afterwards I'm happy to check DMs as well. I appreciate everybody's patience. Hope this wasn't too much Zoom fatigue. I hope everybody enjoys the rest of the conference and more great talks that are hopefully entertaining, informative, and fun. This is the repo I mentioned. This is my Twitter handle, and if you want my business card, which would be coming up in the Apple Wallet, there is a QR code for it too. All right, I'm going to stop right here.
Thank you, Florian. Now everyone can unmute themselves to ask questions or use the Zoom chat or use the Slack channel.
I'm going to look into the Zoom chat. right. I don't see any questions, which I'm taking. This is a little bit lot for this small amount of time. So feel free to reach out after this. I'm more than happy to discuss this.
There's a question from the Slack. Is there a standard or specification for creating server-driven composition in JSON?
Oh, I see this question is from Etienne. I don't think there's a standard or a spec. Everybody is essentially like, right now there is very little information about server-side rendering with SwiftUI. If you look at it, there is like little information, little frameworks. I think there's like 3 different frameworks for people that are doing POCs, but all of the companies that we spoke at the time, and even Apple, were like closed source. So this is rather, there's no standard or spec, and you end up like recreating it yourself. I've tried, or I try to keep it simple and stupid as possible. So what I do is I look into the foundation docs and use the same naming that like the SwiftUI Foundation views use to answer the question.
Cool. Thanks, Viz. Or Florian. Appreciate it.
You're welcome.